Hello there, I'm Michael Fudge, your pontificating professor of all things Python, with another lab walkthrough. This time it's Lab 5 Functions. The 1.1 Ucode solution is really easy, but the why behind it is what the real challenge is. So let's try to figure out what exactly is happening here, because the answer to 1.1 is just math factorial 4. But what's happening here? Well, first in this style up here, we're importing math. And when we import math, we're bringing in a bunch of functions that we didn't write. So if we want to see the functions that we didn't write, we use the dir function in Python. So this will show us a list of these different functions in here. And one of the functions in here is called factorial. Then we can get help on that function by typing help math factorial. Help is another function, and it gives us help on a different function. So it says factorial x, find x factorial. Okay, it really doesn't help us because you might have to Google what factorial is or remember from your schooling days. But factorial is, a factorial of 5 is 5 times 4 times 3 times 2 times 1. So 5 times 4 times 3 times 2 times 1 is 120. 0 factorial is always 1. So 4 factorial should be 4 times 3 times 2 times 1, which is 24. There we go. Okay. So this wasn't really a hard one, 1.1, but the point was to help you understand what import does. Import brings in other functions, and then dir helps us locate what those functions are. And then help lets us get help on those functions. These are tools that you're going to use a lot in the course from here on out. All right, now that we've made it to 1.2, what have we learned? We've learned that you can import other code and write your own code. And in either case, they're both functions. So whether or not you import somebody else's code or you decide to write your own code, like I did here, print title, it doesn't matter. Those are pieces that have been added to your code. So down here in 1.2, it just asks us to use the emoji to print out the bacon, ice cream, and thumbs down emojis on a single line. Now, I don't know which one is which. I'm going to have to make some guesses here. So let's try this. Print emoji, emoji eyes. And then let's put in bacon like this. I don't know if that's right. I'm going to try it. I mean, the only way to find out is to try it. Okay, so that works. So to sort of like spruce this up a bit, up here there's this function called print title. Maybe I want bacon in my title, right? So instead of print, I'm going to call the function I made print title, which prints out a title. See that? And now it's a bigger piece of bacon. So I might print out bacon like this. Bacon, bacon, bacon. Look at that. That's a title. And then it says on a single line, but to print it on a single line, you add ice cream. I think that's the other name for the emoji. There's the ice cream emoji. So, I can print them all in the single line. But what I'm going to do is I'm going to put another line down here where I just print. And then in here, I'm going to put in ice cream. And what was the other one? Thumbs down. Okay. That didn't work because I didn't call the function that turns this into an emoji. See, I got to call the emoji eyes function. So let me put that print emoji eyes this string. And then I should get my ice cream and thumbs down. So bacon, ice cream, thumbs down. Okay, that's 1.2. Okay, in 1.3, we stop with the cute printing and stuff, and now we sort of dive into evaluating a credit card. Now, I don't know if you knew this or not, but any credit card that starts with a 4 is a Visa. Any credit card that starts with a 5 is a MasterCard. A 6 is a Discover, and a 3 is an American Express. So if I look at this card number here, because it starts with a 5, I know it's a MasterCard. So we can write an algorithm to solve this problem, and here's the algorithm that I wrote. And then down here is the code I wrote based on the algorithm. And what you need to do is debug this code, because when you run it, it doesn't work. You'll see that it has some errors in here. So let's do what I like to do when I debug, which is, I could go right to this line and try to figure out, but let's holistically try to figure out what this is doing step by step. So we input a credit card. Then we get the first digit of the card. Then we're doing a series of checks. If the digit equals a 4, okay? Well, this one says if the digit equals a 5, so I know I already got to fix that. That's not right, okay? Then the issuer is a Visa. That looks good. Else if the digit is a 5, then it's a MasterCard. Else if the digit is a 6, oh, that's not the right equals. It's like that. Then the issuer is a Discover. Else if the issuer is a 3, then it's American Express. And then anything else should just be invalid. So let's see if I got it working now. Okay, I'm missing... Oh, the classic invalid syntax here because I'm missing a colon. Just like that. Okay. I think I got all the fixes. So let's try it. 4, blah, blah, blah. That should be a Visa. Okay, let's run it again. 5, blah, blah, blah. That should be a MasterCard. Oh, it's a Visa. So what did I do wrong? It looks like it should be right. Let me run it again. Let me try something with a 3. American Express, okay. 6 should be Discover. It says American Express. All right, so what is happening here? Oh, yeah, it's not issue equal to. It's issue single equal to. Oh, man. Okay. Got to know the difference, right? This equal says equal to. This equal says take Visa and put it in a value. So that's why MasterCard and Discover were working, because I had the double equals there. I need the single equals. Tricky bug to catch. I think I got it now. 3, American Express. Good. 4, Visa. 5, MasterCard. 6, Discover. Good. Anything else? Invalid. Okay, good. So you have to test all 5 cases, or else you don't know if it works. That's important to recognize. You got to run it 5 times. It says make sure to test your code, ring it 5 times. You should test issuer and also the invalid card case. All right. That's 1.3. Okay, now in 1.4, we introduce an approach that is commonly used in functions where you write code and then refactor it into a function and then test the function. Okay, so this 1.4, I'm going to do this 1.4 here, and then I'm also going to do these tests here. And then I'm going to finish out 1.6 with a rewrite. So this is 1.4, 1.5, 1.6. I'm going to do them a step at a time, but you really kind of have to do them all at once to really see the big picture. So the first part is to refactor this as a function. Now, the way functions work is they imply a variable as input and they return a variable as output. So rather than doing something like this in our function, we will assume that data is going into the function as input. Rather than doing this in our function, which prints, we will assume data is coming back as output. This is how you write a function. So I should not have an input in here. What goes into the function should be the card, and what goes out of the function should be the issuer. So the rest of the function, I think, will follow along fairly well. And I want to get them both on the screen. So I'm going to move this down so it's closer so that you can see them both. Okay, so here's my function that I'm going to write. I'm going to say digit is card 0, the first item in the card, 4, 5, 6, 3, whatever. Then I'm going to say if that digit equals a 4. You can see it's going to be very similar to what we already had, if not identical. Issuer is a Visa. Elif digit is a 5. It's good to write it for practice. Don't copy it. It's too early in the game for us to be copying code. copy the code once you've mastered it. Okay? When you're learning it, get in the practice of writing it. It's going to make you better as a programmer. This should not be, this should see issuer 6, right? Digit equals a 3. Issuer is assigned American Express. American Express. Else we want to say invalid is invalid. Okay, and then we return the issuer. Now when you run this code, you'll get syntax errors if you don't do things right. But if you do things right and run this code, you'll see that nothing happens, because the only thing that really happens here is if I say dir to the root namespace, you'll now see there is a function called card issuer. Do you see that? That has been added to Python. And if I say give me help on card issuer, it's going to say this. Now maybe I wanted to say something better than that. I can write code comments up here like this. I can say in these apostrophes, I can say input a card number, and this will return the issuer. Visa, MasterCard, etc. So that's my little documentation, right? So when I run this code now, it's now documented. See, card issuer card, input a card number, this will return the issuer. Okay, so I have a little, how do I call it? Okay. That is, I know I lost it, but that is 1.4. Okay, that's a refactor. Again, you don't know if this code works till you test it. That's 1.5. All right, now in 1.5, we're going to take the code that we wrote in 1.4, and we are going to call this function. We're going to invoke it. We're going to use it to see if it's right. Okay, this is called black box testing, because we are going to assume that this works, and we're going to figure out what we expect, right? For example, if you were to input this card number, what is that card? That's a Visa. So you would expect it to say Visa, and then you say actual, and then over here you call the function. So I'm going to run these two. So it says when the card is for blah, 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 we expect the card issuer to say Visa, and the actual output is Visa. So this function is working for Visa. When the card starts with a 5, we expect it to say MasterCard, and it says MasterCard. So can we write the other remaining tests? Well, they work similarly. You're going to say something like this. Print when card starts with a 3, I'm just making a card number up, we expect card issuer for that card to return back Discover. 3 is American Express. And then actual, what we get back is, let's call it card issuer okay, let's see what we get. I got an error because I can't type. Print. When it's an when it's a 3, we expect American Express, and actually it is American Express. Good. Again, you got to do this 2 more times for discover and invalid. Do not copy your code. I would copy my code because I'm good at Python. You're learning. Don't copy it. Practice typing it. This is how you get better. It begins with a 6, right? So when the card begins with a 6, we expect the card issuer for that card to bring back... I kind of like the arrow better, I gotta be honest with you. I don't know why. We expect that to say discover. The actual output is card issuer. And then let's put in that same card number I have over here. Now I can copy that. You know, 'cause that's just a series of digits. All right, let's see. Does it work? So we expect discover, and it is discover. Now, let me show you what happens when your function's not right. Let's go up here and change discover to Visa. And then I'll rerun this function. That's what I just did. I just reran it. Then I'm going to come down here, and we're going to run our tests. And we're going to see it expects discover when it's a 6, but it actually returns Visa. So that tells us that there's a problem when you input discover into this function. And now you can debug it, because you know when you input discover as the card, that it comes down here to, it begins with a 6, and it gives you back a Visa. So I should say, when you input a card that begins with a 6, it says Visa, but here it should say discover. There we go. So I need to rerun this so that it's redefined. Then I can go back down here and retest. And now they make sense. It says discover, and it's actually discovered. So let's do the last one for an invalid card. So print when card. Let's just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We expect card issuer for that same card number to return back invalid. And then actually, it's going to return back. Let's find out. Should say invalid. I'm going to copy that because I'm not confident that I can do it right. So when the card is 00000, we expect invalid, it's actually invalid. So you have tested this function. So the moral of the story here for 1.5 is if you write your own function, how do you know it's right? You got to run it. This function, we saw when we ran it up here, you had to run it 5 times this code to see if it was right. So we had to write 5 tests for it. Do they always have to be so lengthy? No, you could probably get away with writing your tests like this. Print for blah, blah, blah. Visa. And then card issuer. And then let's put in this same value here. So blah, 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 blah should be a Visa, is a Visa. Okay? As long as you know what you're looking at the output, you know it's right. Okay? That is 1.5. All right, to finish off the write, refactor, rewrite approach, see it's write, refactor, test, rewrite. So we wrote it, we refactored it, we tested it. Now we got to rewrite the original program up here that inputs a credit card and prints out the issuer. So this is now a 3-step process. Input the card. Enter a credit card number. Figure out the card issuer. So we're going to do this. We're going to say, issuer, card issuer, and then we're going to pass in the card as input. That's our function that we wrote. And then we're going to print, let's be fancy about it with an F string, for card number card, the issuer is issuer. Enter a credit card number, 5 something. For card number 5 something, the issuer is MasterCard. Let's run it again. 3 something. For card number 3 something, the issuer is American Express. So you can see our code got simpler because we used our own function. And that's the purpose of functions, is they abstract away complexity from us. It's just like driving a car. You don't have to be a mechanic to drive a car. Step on the gas, car goes. Step on the brake, car stops. Turn the wheel this way, car goes left. Turn the wheel this way, car goes right. That's all there is to it. Well, there's more to it than that. But we don't have to be an engineer. We don't have to be a mechanic to know how to run a car. It's just an abstraction that we can interface with. Okay? You don't have to be some kind of engineer to use an iPad, right? It's just, pretty easy and simple to use. That's, again, a nice, healthy abstraction. Software is all about abstractions. All right, so here I am down in 1.7 where we're going to put all of this stuff we did in this lab together. We're going to use all of these functions to create a really cool and interesting program that allows us to check credit cards. And one of the things that we'll use is this LUN check. You can see that there's a function that we wrote which algorithmically checks to see if a given credit card number is a valid credit card number. So if I run this LUN check and then I come down here and run these 2 tests, the first credit card number passes the LUN check. That means it could be a real credit card number. The second number does not pass the LUN check, and therefore it could never be a valid credit card number that was issued by a bank. Okay, this says no guarantees that it is a bank credit card number. It just tells you that it passes the algorithm that banks use to verify that the card is correct. Okay, so let's try to follow this algorithm and use all of our functions in the process. Okay, we might have to do this in 2 steps. So it says print the title credit card validator. So this is going to be print title. That's a function that we wrote. If you don't remember all the functions you wrote, you can do a dir and get a list of them all in here, right? They're going to be in here: print title, print normal, interact manual, okay? So I'm going to do a print title, and then let's print out credit card validator. There we go. Well, there's my title. And then it says write an interact function with the card as input. Okay, so I don't know if you remember how to do this. If not, you can always go up here and look where we did it up here. So you pass in an interact manual, and then you make a function. It's basically how it works. So I'm going to come down here and say at interact manual, and I'm going to pass in a card, and then I'm going to say def main. I'm just going to call it main, and then I'm going to say card, and I'm going to give it a value of empty to start. And then what I'm going to do is just I'm going to print the card. So I'm going to run that. And I goofed something up. Where did I goof it up? I think I say card equals here, like this. And then this, I don't say card equals. That's where I goofed it up. There we go. And so now it's asking for input. This is like a fancier way to do input and output rather than the way we've been doing it. So I can enter my card number here. And then I can run the interact. Okay, and all it does when I run the interact is it runs this function. And the only thing this function does so far is just print out the card. It's not very fun at all. Okay. What we want to do is we want to get the issuer. So let's do that. Issuer equals card issuer for the card. Then it says if the card passes the LUN check. Okay. So if check LUN for the card, L-H-U-N, did I do that right? Check L-U-H-N. L-U-H-N. If that is true, see, check LUN returns true or false. true or false. It returns a Boolean, so that's why I can just say if check lun card. I don't have to say something like if check lun card equals true. That's asking if true equals true or false equals true. You don't have to do that. That's redundant. So then I want my emoji. I don't know what we're going to call it. We're going to call it OK equals thumbs up. Oh, man. Else, okay. I have to give it a variable name, right? Thumbs down. Down. So that's this part. And then it says print in normal text the emoji icon and the card issuer. So I'm going to do that now. I'm going to say print with an F string, and I'm going to print, oh, I got to do emoji eyes, right? Emoji eyes. Like that. And then I want to print the thumb up or thumb down. So I'm going to print OK, and then the issuer. So it's going to go Visa invalid or Visa if it doesn't pass the LUN check, right? So let's run it and see if it makes sense. So let's enter the card for blah, blah, blah. This is going to be a Visa, but it's not going to pass the LUN check, so we're going to get a name error because I screwed something up. I think I spelled check LUN wrong. Yeah, it's a little c in the check LUN. See that? For blah. It says thumbs down Visa. Okay, so I screwed up the emoji. I need the colons on both sides to make the emoji work. Let's try it now. 4. Oh, my goodness. Have mercy on my soul. Can't hit the right button if I want. 4. Ah, thumbs down Visa. The thumbs down means it does not pass the LUN check, and the 4 makes it a Visa. So I can. What's cool about Interact is you can run it again. Let's put in something else. 6. That's a discover, but it doesn't pass the LUN check. Now let's go find some cards that pass the LUN check. I'm going to go here to this website. And we're going to go get ourselves this MasterCard right here. That one passes the LUN check. We're going to paste it right in here. We're going to run our Interact. MasterCard passes the LUN check. Let's do one more for fun. Okay, this one here passes the LUN check, and it's an American Express. American Express. Okay. So that is functions. I know it's a lot, but really it's not, okay? We learned a couple things. 1, how to import our own functions, how to import other people's functions. 2, how to write our own functions. And 3, how to build an Interact with a custom function so that we can use a different UI in Python. Okay. All right, thanks for watching. I hope it was helpful. Goodbye now.